What's up, guys? Just want to make a quick video going over our problems today, our practice problems. And these problems were basically just taking word equations and putting them into an actual chemical equation. So I'm just going to go over 3 of our examples that we did in class so that you guys can be good for your homework. And we'll go ahead and get to it. I did forget my pen, so this might be a little rough, but we'll make do with what we got. All right, first thing first, what you're to do is you're going to read your equation, kind of interpret what's going on. So what are your reactants? What are your products? So it says aluminum oxide powder decomposes to produce aluminum and oxygen gas. Okay, so you see the word produce here. That's a key word that tells you, okay, if it's being produced, those are probably going to be my products. So if those are going to be your products, then we're going to be putting those there. Can I make this any bigger? I don't know if I can. Ooh, that's kind of thin. All right, whatever. So we have aluminum metal and we have oxygen gas as our products. And I give you those formulas in the equation. I give you, in parentheses, those formulas. But notice over here where it says aluminum oxide powder, I don't give you the formula for that. So that means that I'm kind of counting on you to understand how to get it. So aluminum oxide, you should be able to recognize that that's an ionic compound. Why? Because it's a metal bonded to a nonmetal. Aluminum oxide is going to be ionic, which means it's made of charges, which means if you go back and look at your periodic table, you should be able to tell the charges of aluminum and oxygen and be able to figure out a compound from that. So aluminum has a 3+ charge. Oxygen has a 2- charge. So based on those, you know that you're going to need a certain number of each of those in order to cancel out the whole formula. What do I mean by that? Well, if you have 2 aluminum, then you have a total of 6 positive charges because each one contributes to 3+ charge. If you have 3 oxygen and each contributes 2-, then you're going to have a 6- charge. Therefore, that gives you enough to cancel out the overall charge. The 6 positive charges cancel out the 6- charges. So what's the formula then? Aluminum oxide must be 2 aluminum, because we have 2 aluminum here, to every 3 oxygen. So it'd be Al2O3. Okay, and so let me just erase this. So that's how you figure it out. You got to figure out from the charges. All right, so now we were able to, from our equation, from the word equation, put it into an actual equation. Okay, fair enough. So that's the first thing. Now we're going to balance it. So now we need to balance it to make sure it's all even. So this is where we do the counting. So if we're to do the counting, we have aluminum and we have oxygen on both sides. Okay, on the left side, I've got 2 aluminum and 3 oxygen. On the right side, I've got 1 aluminum and 2 oxygen. Okay, well, let's go ahead and why not just go ahead and start balancing out. We're assuming we have 1 of each of these compounds. And we recognize that we're going to double our aluminum on the product side. So we're going to change that 1 to a 2. So change that 1 to a 2. And now that doubles our aluminum. Okay, so now that's even. But now we come down to oxygen. We recognize, okay, that needs to be evened out. Well, how do I even out 3 and 2? Well, they're going to meet at 6 here. Okay, so how do I get 6 oxygen on the left and how do I get 6 oxygen on the right? Well, I'm going to have to, on the left side, I've got 3. And if I double that compound, this whole thing, then I'm going to get my 6 oxygen. So that's what I have to do. So that gives me my 6 oxygen because I've got 2 of that compound, and one of those compounds contains 3 oxygen. So now, but because aluminum is also in that compound, I got to double my aluminum. So now I've got 4 aluminum. Well, that kind of sucks because I just balanced aluminum, but it is what it is. On the right side, if I want to get my 6 oxygen, now I change that 1 out in front to a 3 because if I triple my oxygen, if I triple this, then I'm getting my 6 oxygen from that, okay? All right, so my oxygen's balanced. I got to go back and I got to rebalance my aluminum. So in order to get 4 aluminum on the right side, I got to change that number out front, that coefficient, to a 4. Okay, so that's the balancing part. The only last part that we added today was identifying the state that these compounds are in. So remember, there's solid, there's liquid, there's gas, and then there's something called aqueous. Aqueous just means that it's dissolved in water. It's some sort of solution. Okay, so let's take a look at what we got here. We have aluminum oxide powder. Okay, well, what state is powder in? Powder's a solid. So all we do is at the end, we just put an S in parentheses. Okay. That's it. All that does is that signifies that tells you what state that compound's in. It produces aluminum metal. Okay. If it's producing aluminum metal, that's a solid. And oxygen gas, if it's just gas, that's a G. Okay. And then that equation is completely done. All right. So if you got it balanced and you got the labels for the states, then you're all good. All right. Sand reacts with aqueous hydrofluoric acid to produce silicon tetrafluoride gas and water. Fair enough? Let's go ahead and dissect this a little bit. What are the reactants? Well, it says sand reacts with aqueous hydrofluoric acid. Okay, fair enough. So those are the two things that are reacting. So let's go and write it down. We got sand, which is SiO2. And we got hydrofluoric acid, which is HF. What's it producing? Silicon tetrafluoride. I don't give you the formula for silicon tetrafluoride, so what must it be? Well, the tetra, if you remember, if it has a prefix tetra, you must be dealing with a covalent compound. That's actually a good thing because now it's telling you how many fluoride you have. So silicon tetrafluoride, tetra is the prefix 4. All it's doing is it's telling you got 1 silicon and 4 tetrafluorine. So this would be SiF4, okay? And then lastly, it says it produces liquid water. Well, hopefully by now, voice crack, you should know what liquid water is or what the formula for water is, and that's just H2O. All right, so now what we do is we are going to count how many we have on each side. So we got silicon, we got oxygen, we got hydrogen, and we got fluorine. And do the same on the left in the same exact order. Okay. All right, so on the left, I got 1 silicon, 2 oxygen, 1 hydrogen, 1 fluorine. On the right-hand side, I got 1 silicon, 1 oxygen, 2 hydrogen, 4 fluorine. Fair enough, okay? So let's start balancing. My silicon's good, 1 on each side. My oxygen, I need to double my amount of oxygen on the right-hand side. And remember, all these start as 1. But I need to double my oxygen on the right-hand side. Well, fair enough, okay? The oxygen on the right-hand side here is going to be inside our compound H2O, which means I need to double my whole H2O, okay? So by doing that, you put a 2 out front, and now you're doubling your oxygen, so now that's a 2, but you also have to double your hydrogen because hydrogen was included in that compound, so now you have 4 hydrogen, okay? So silicon's good, oxygen's good, but we recognize that hydrogen and fluorine, now they're both not balanced, okay? I've got actually 4 times more hydrogen and fluorine on the right side than I do the left side. Well, this actually makes balancing easier because on the left side, we see that hydrogen and fluorine are in the same compound. So what number do I got to put out front of HF, hydrofluoric acid, in order to balance it? I just got to change it to a 4. That's all. So if I put a 4 out front here, I'm quadrupling my HF, which means I now have 4 hydrogen and 4 fluorine. Okay. So I'm all balanced now. And the last thing we got to do is we got to add our state identifiers. So sand, what state is sand? That's a solid. So you just put S in parentheses. Hydrofluoric acid, I tell you that it's aqueous. Okay, fair enough. So you put AQ. All right, it produces silicon tetrafluoride gas. All right, I tell you it's a gas, so it's just a G. And H2O, it says liquid water. H2O is always going to be either, well, I guess it could be liquid solid gas. It's never going to be aqueous, though. You can't dissolve water in water. But that's what you got. And if we had more space, then obviously I wouldn't put these things underneath them. You don't want necessarily to write over the plus signs and stuff like that, but that's what we're working with right now. So this is what we're doing. We're taking our equations, the word equations, putting it into an actual equation, balancing it, and then adding our state identifiers. I'm not going to go over this one because this one's kind of higher level. The only thing that you need to know about this one is like the trickiest part is iron 3 oxide, how to get that back, and how to get that into an actual chemical formula. I'm not going to do this because this one was pretty difficult, but I will tell you how to get this. Iron 3 oxide, we understand and we remember that iron's a transition metal. That 3 that comes after iron tells you the oxidation number of that iron. So it's going to be 3+. That's what that 3 tells you. And then oxide, oxygen is going to have a 2 minus charge. And then now this problem comes in becomes more so what we dealt with aluminum and oxygen in the first problem. So I need to make a compound out of Fe3 plus and O2 minus. Well, they're going to meet at 6 again. So if I have 2 iron, that gives me a total of 6 plus. And if I have 3 oxygen, that gives me a total of 6 minus. So my compound here is going to be, I've got 2 iron to every 3 oxygen. So that's what would go up here. But again, I'm not going to go through and do this problem because this was a little bit higher level than I would ever quiz you on. Okay. So let me know if you have any questions. Hopefully this helps out. But again, this is just a good review for what we're going to be doing on our homework and for our quiz.